All right, so another way to write the first one, 2 to the, how many is there, 7? So 2 to the 7th power. To rewrite the second one, that'd be 4 to the 5th power. To rewrite the third one, x to the 3rd power. Essential question. When multiplying numbers or variables over and over, how do we do this quicker? So let's write these 3 problems down. Let's say we have 2 to the 3rd times 2 to the 4th, and squared times n to the 7th, and 3 squared times 3 to the 3rd times 3 to the 1st. What's going to happen is I'm going to write out the work to the right of it, but you're going to write the work below it, since that's the way the setup is. Anyway, I'm going to completely write out 2 cubed is 2 times 2 times 2. 2 to the 4th is 2 times 2 times 2 times 2. And then we'll develop a rule, just like last week. So you've got really 2 to the 7th power, if I want to rewrite it. So with the n's, I can rewrite that as n to the 9th.
There's too many.
And then writing out the 3's. So the first group of 3's, we've got 3 times 3. Then the second group of 3's, 3 times 3 times 3. Wait, 3 times 3. Ugh. And then we've got another 3. So that's a total of 6. So this would be 3 to the 6th. Let's write down this rule. Most of us discovered this last week. When multiplying the same bases, we can add the exponents. So first off, when we talk exponents, I'm literally talking about the A position and the B position. So let's write down the word exponents above your equation that you see next. And either draw an arrow, or if you have a highlight, however you want. Or make them bolder, circle. But exponents are these pieces above. Bases, anytime you hear bases, because it says here, when multiplying the same bases, bases are these numbers in this position, or these letters in this position. To finish out our rule, how we can add the exponents, I want equals x to the a plus b. How the base stays, but the exponents are added together. So I want to go through examples 4, 5, and 6. Go ahead and, oh, these are already written down. But I want you to realize different situations. In example 4, they do not have the same base. So, not the same base. Because they're not the same base, the answer would just be left alone. X cubed, y to the 4th. So if you do not have the same base, you cannot add exponents together. In the second situation, this is all multiplication because in between the parentheses there's no symbol, so we assume still multiplying. But we can only get the same bases together. So the L combination, I like to write my L's in cursive. That way it doesn't look like a 1. And so when I go back to my notes, it's not as confusing. But I'm going to write out some notes. So L's exponents are 2 and 3. And now K's exponents are, wait. Let's say I don't see an exponent. If I don't see an exponent, I'm going to assume there's a 1 in the exponent position. So this is like K to the 2 plus 1. Ending answer, L to the 5th, K to the 3rd. So what if we have these things called coefficients? These are called coefficients. These are treated normally because they are in the normal number position that we're used to. So we just multiply 5 and 4 together like normal. The other ones, whenever you see a base and an exponent with each other, now I have a to the 7 plus 2. So the final answer would be 20, a to the 9th. So in the next examples, 10 squared cubed means you have 10 squared times itself 3 times. So 10 to the 2 plus 2 plus 2, ending at 10 to the 6th. So if I have 3pr squared, then I'm going to put, 3pr squared times itself 2 times. So I've got 2 coefficients, and I multiply those regularly because those are just normal numbers. We've got 9. P doesn't look like it has exponents, but there's actually 1s there. So this is p to the 1 plus 1. R to the 2 plus 2. Final answer, 9p squared r to the 4th. So in the next one, we've got 2a to the 5th b squared times 2a to the 5th b squared times 2a to the 5th b squared. So regular numbers in front, the 2 times 2, that's 4, times another 2, we're at 8. A to the, and then if we count a's exponents, we have a to the 5th plus another a to the 5. B, we have b to the 2nd, b to the 2nd, b to the 2nd. I'm running out of room, so I'm going to write my answer over here. Looks like 8, a to the 15, b to the 6th. So if we flip a coin 3 times in a row, there are 2 to the 3rd outcomes that can occur. Like we could either get heads 3 times, we could get heads the first time, tails the last 2 times. We could get a head first, tail second, head last. We could get 2 heads, then a tail. So we can go through this list. These are all the possible outcomes of what we could possibly flip if we got a coin and flipped it 3 times. And it says that this is the same as 2 to the 3rd outcomes. Wait, 2 to the 3rd outcomes, what does that mean? So in our statistics class, we'll go through how this probability is developed. How on the first flip, you have 2 choices. It's either heads or tails. On the second flip, could be 2 choices, heads or tails. And on the third flip, you could have 2 choices, heads or tails. So this is how they got 2 to the 3rd. So let's say we flip the coin 2 more times. Then that means you're going to have that same 2 to the 3rd times, well, wait, if you flip it 2 more times, that's like 2 to the 2nd power. How many outcomes can occur if you flip the coin, as mentioned above, 4 more times? So let's say we not only flip it 5 times, but we flip it 4 more times. And we're going to write our answer in the form of 2 to a power. You flip it 3 times, you flip it 2 times, and then you flip it 4 more times. So how many possible outcomes could we have? We have a possibility of 2 to the 9th outcomes. So on Khan Academy, just look at my screen for right now. Some of your examples might say, find what x would have to be in this situation. So if you had, so it's trying to stretch your knowledge. So like what we did in notes only gives us a branch of how to interpret this rule we developed. So if you have 7 to the 3rd power times 7 to another power, how do we get, what would that power have to be in order for 7 to the 9th power to be our ending result? Not only that, sometimes it's also going to make you find the base. What would this base have to be in order for this to work? So the second assignment tries to stretch your thinking of, if I take a piece out, would you be able to find that piece?